Hey Dr. Wilson, this is John Driscoll, and this is my group's first regression analysis project. So what we're looking at here is we're looking at the Accounting 200 grades from the fall of 2017. See all the way from A to F's, we have all the students, we got all the exams, all the exercises, all the bonus, all their grades here. And so here's a few things we want to do to our data before we try running a regression analysis to see which one of these exams or exercises have the biggest impact on their final grade. And so first things first, we're going to make sure that our data is in vertical format, which it is. We're also going to make sure we don't have any empty cells. So anywhere we see a 0, I went ahead and filled it in. There was an empty cell. And so since it would be them not submitting the project, it's easy to put a 0 there because that's what they would have gotten. And so before we run a regression analysis, the first thing we want to do is run a correlation analysis. And this is going to do a couple things for us. This one is going to help us find different variables to use for our regression analysis after. And also it's going to make sure that none of our independent variables are correlated with one another. So to run this correlation analysis, we had to do a few things. First, we got our maximum possible score. We went ahead and shifted that with our total points earned. And we went over to data, and went to data analysis. We're going to go ahead and click correlation. And let's see here, we're going to click the labels in the front row, and we're going to grab all of our data. So we're going to go from the total points earned here in the top left, we're going to drag it all the way down to here in the bottom right to make sure all our data is gotten. So let me exit out of this since I've already ran it. So this is what we get right here. And so I had to tweak the headers a little bit to make them correlate with our guy over here. And that is how we get our correlation analysis.
Okay, for the use of this correlation analysis, we will be using this information to select which variables are highly correlated with our dependent variable, which is the outcome of the total points awarded to students taking the Introduction to Accounting course. Here I have highlighted in green the selected variables that we have chosen for our regression analysis, which is exam 1 and exam 4. We will be choosing these because they are highly correlated with the dependent variable, but not highly correlated with one another. It's important that no multicollinearity occur in our data because that would result in an unreliable prediction to the final grade for the students.
Talk about the equation regarding the regression analysis and correlation that we did on Accounting 200 Grades Fall 2017 doc. From this 2017 doc, we were able to choose two variables. The two variables that we stuck out were Accounting 200 Exam 1 and Accounting 200 Exam 3. From performing the regression analysis on this data provided, we were able to come up with a summary. The summary provided showed us an R-square of 90%. This means that we're able to relate the information provided in Accounting 200 Exam 1 and Accounting 200 Exam 3 back to the intercept. This meaning that the grades that you got on those two exams would sufficely be able to show you the calculation of your overall grade in that class. As well, from the information provided, we were able to see that our significance F and our p-values for the intercept and our Accounting 200 Exam 1 as well as Exam 3 were all under 0.05. Being under 0.05 means that our equation can satisfactorily guess your grade for this class, provided off if you get a 100, a 90, just depending what you want your total grade in this class to be. Our p-value for our intercept is a little bit high. With this being a little bit high, there may be a standard error or even a little bit standard deviation. Now, with this being held in account, this would show you that even if you did a little bit of point average off, the little standard deviation would help you get to that 100%. So this does mean that our equation could provide a little bit of off calculations, but it is 90% related back to the intercept and would 90% sufficiently show you what your total grade in your class is, provided based off the calculations. Now, from the equation provided, I was able to set up an equation. The equation was set with the final grade equal to a y-intercept plus our variable 1 plus variable 2. With this being provided, I was able to pull the coefficients. The coefficients would lead our intercept as a y-intercept, exam 200, exam 1 as variable 1, accounting 200, exam 3 as variable 2. With these being our variables, you would have to times these numbers to 100. This would turn them into a point value. With those point values, you would be able to add your y-intercept to. These y-intercepts would then allow you to add all two variables and the y-intercept and equal your point average. This point average would then be able to be divided by 500, allowing you to see your percentage in that class. Now, as you see for your final grade overall provided off the regression analysis that was performed, you would have a 98%, and that would be the same as you could see for your final grade as a 100. And this is only because that standard error in the p-value of 0.36. This would show our little equation is a little off. As well, for the grade 90 and the grade 75, you would perform the same calculations as provided in grade 100, and you would do this for 90 and 75. So for all of them, you would pull the y-intercept 11.82. By pulling this y-intercept, this is a dependent variable that stays the same. Your independent variable can be changed, and this is the percentage that you want your grade to be overall. The coefficients will always be the same, but that x that we are changing is going to be that independent variable, which is going to be that percentage that you want your grade to be. Now, this would be any of those coefficients times 90%, and you would do that to find your 90% in that class, and as you can see, it's 89.15. Now, with this being just a little bit off, like I said, that standard deviation would put you at a 90, which overall your grade for this class would be a 90, allowing for your equation to be satisfactory in guessing your grade for your Accounting 200 class, basing it off grades that you put in.
I'm Teresa Mize, and I'm going to be evaluating the data set with the students that made a C or higher. I chose to evaluate this data set because if our student that is asking what to expect when going into Accounting 200 is a more serious student, then this data might be more accurate and more relevant to them than the data set with zeros for people who either didn't do their assignments or may have dropped the class. So the data set here shows students that made A's, B's, and C's, and I did calculate a new class average of 85.5 just to show the difference between the two data sets. So I already did run my correlation, but I am going to show how I did it. So first we want to go to data and then data analysis, choose correlation, and then you need to select the data that you are going to evaluate. And then make sure that you've marked that labels are in first row, and then you would hit OK. So here's my correlation, and I evaluated all of the values that range between 0.5 and 0.99. I evaluated that range because values in this range have a high degree of correlation. So we can see here that exams 1, 2, and 3 highly correlate with our final grade. So next we want to evaluate the rest of our variables to make sure that they are not highly correlated with each other. And we could see that exam 2 is both correlated with exam 1 and exam 3. So we are just going to evaluate exam 1 and exam 3. So again, I did already run my regression, but I am going to go and show you how I did it. So again, we'll go to data and data analysis. And select regression. So our y range is our dependent variable, so I already have total points earned selected here. And then our x range is going to be our independent variables, which are exams 1 and 3. You'll select these, make sure that labels is selected, and we do want this on a new worksheet. So here's the regression outcome. We see here that our R-square indicates that 67% of our final grade is dependent on these two variables. We can see here on our significance f that our value is 0, and a value that is less than 0.5 means that it is a good model. Here our p-values are also 0, and again, less than 0.5 means that these are good variables to have selected.
Hello. Once we get our regression statistics summary, we use the results to perform a multiple linear regression equation. The reason why we want to perform a multiple linear regression equation instead of a singular linear regression equation is because we have two independent variables. We have exams 1 and 3 as our independent variables, and our intercept dependent variable would be our class average. Here at the bottom, I have the formula y equals y-intercept plus variables 1 and 2. Here we have the test score results that we would get, and then how that affects our overall average. For example, if a student scores 100% on both exams 1 and 2, they would get an overall average of 100%. Here at the bottom we have another example. If a student scores a 90 on both exams 1 and 3, they would have an overall average of a 93. And then here at the bottom, if a student scores an 80% on exams 1 and 3, they would have an overall average of 86%. In this case, the professor allows the students to get bonus points. These can help the student get up to 106% overall average, right here. However, most students aim to get 100%. Regardless, even if they don't get the extra bonus points, they'll still make 100%. They can still have 100 overall average. And that's how we get our class average predictions.